Welcome to the video for lesson 12.4, day 2. And this lesson is going to take the idea of the derivative and we're going to take it a little bit further. And we're going to do something called the Product and Quotient Rule. And so this is at the end of section 12.4. It's the last 2 pages. I'd like to first begin with a review of the derivative. So if we have a function, f of x equals 4x to the 5th, and I want the derivative. So the derivative of that function is simply the 5 times the 4, right? So we're going to have 20x, and then you reduce the exponent by 1 to the 4th. Very simple derivative. All right. Now let's introduce another function. So we have almost like a composite. So we have function f that's 4x and g of x that's x to the 4th. And I'd like you to find the product of function f and function g. So what that means is that we're going to take function f, which is 4x, function g, which is x to the 4th. We want the product, which is 4x to the 5th. Well then, if we want the derivative of the product, we simply take the derivative. Remember, this is another way to write the derivative, and you'll see it many different ways. That's why I'm writing it different ways. We want the derivative of the 4x to the 5th. Well, you know how to do that. That's just simply 20. We just did that. 5 times 4 is 20. X, reduce the exponent by 1. So you can achieve the same derivative even if you're starting with 2 different functions and you're taking the product, as just because you will arrive back at 4x to the 5th. Now I want to talk about a very important differentiation here, and that is if you want the derivative of a product, let's write this out. The derivative of the product of function f and function g, that does not equal the derivative of f times the derivative of g. You cannot do that. If we look at these 2 functions right here. So this derivative of the product, we just found it. It was 20x to the 4th. Here, the derivative of function f is right here. The derivative of 4x is simply 4. The derivative of g is, right, bring the 4 down times the coefficient of 1 in front, so that's going to be 4x to the 3rd. Well, that equals 16x cubed. Okay, you can see that those do not equal one another. So you can do this with addition, right? You can take the derivative of each term or the derivative of the sum. Here you cannot do that with multiplication. You cannot split it up and take the derivative of each one and then multiply it. It's not equivalent. Very important that you remember that. Let's try another one. Here's example 3. The function f is x squared minus 4, and g is x squared plus 5. We're going to find the derivative of the product. So let's write that out. I want to know the derivative of x squared minus 4 times g, which is x squared plus 5. Well, that's just 2 binomials right there. I can take the derivative of that. But you know what? It will be even easier if I just distribute, FOIL it out. That's going to be x to the 4th My middle term will be negative 4x squared and positive 5x squared. So I'm going to have a positive x squared. It's my middle term. Last term, negative 4 times 5 is negative 20. Now I can take the derivative of each of those terms very easily, right? The derivative of x to the fourth is 4 times 1, reduce the exponent, 4x cubed. The derivative of x squared is simply 2 times 1, which is 2, reduce the exponent, I have 2x. The derivative of 20 is 0. So my derivative is 4x cubed plus 2. Now, I would like to introduce something called the product rule. The product rule is a way to take a derivative anytime you have two functions that are multiplied this way. Do you always have to use it? No, because you can just distribute this way and take the derivative of each term. There will be, however, times when these two functions are going to have trig values in them. And then you will not be able to just distribute and FOIL and take the derivative. So we need another process. We need another way to take the derivative when we have trig values in our functions. So I would like to introduce the product rule. Let's get a good color here. The product rule yes, you have to have it memorized, but it's not going to be that bad, and it's very easy. So let's take, you're going to take first the derivative of the first function. So we're going to take the derivative of f, and then we multiply that times the g function, plus. Then we're going to take the derivative of the g function times the function f. So it's not that hard. That's it. That's all you need to remember. You should take the derivative of f times g plus the derivative of g times f, and then you will combine terms and simplify. So let's take this function let's take this one right here. So if we were here and we had x squared minus 4 times x squared plus 5. Now, remember, this is f, and this is g. Okay? Then let's apply the product rule. We're going to first take the derivative of f. So I'm going to do that in my pink. The derivative of x squared minus 4 is simply 2x times the g function plus the derivative of g, which the g function is x squared plus 5, so the derivative of that is also 2x, times the f function, which is x squared minus 4. Now basically we're done, and now we just have algebra to do. We're just going to combine like terms. So this is 2x cubed. This is 10x plus 2x cubed, and 2x times negative 4 is negative 8x. Now combine like terms. So I have 4x cubed, and I've got a positive 10 and a negative 8, so I have a positive 2x. Well, look at there. We got the exact same derivative. We must have done it right. Okay? Now, when you look at this, we FOILed that out and we took the derivative of each term. Here, we took the derivative times the other function, the derivative times the other function, we had to combine like terms. Yes, there is an additional step here. But as I said before, there are times when you will not have a choice and you will have to do it with the product rule. Okay? In our class, for our assignment, we want you to do this. We want you to practice the product rule. If you want to multiply it out and check your work easily that way, that is just fine. All right? Let's set up and do another example. Okay, here's example 4. We'll see how far we get in this video. I may stop it mid-problem here and we'll pick up in a minute. All right, so we have two functions. Function f is a binomial, x to the 5th plus 13x squared. And function g is a trinomial, 7x cubed minus 5x squared plus 18. And I'd like you to find the derivative of the product. So I've written this out, and I've written function f times function g. So, if you need to label that, you can identify what those are. Let's write the product rule just for grins so that we can practice it. Right? So we have the function of f times the function of g plus the derivative of g times the function of f. All right, here we go. So first I'm going to take the derivative of function f, and I'm going to scoot over even more here. All right, that's bring down the 5, so I'm going to have 5 times 1, which is 5x to the 4th. And I'm going to have 13 times 2, which is 26x. That is times our g function. So I'm going to recopy that. 7x cubed minus 5x squared plus 18. Plus, now I'm going to take the derivative of the g function. Here we go. That would be 7 times 3, which is 21x squared. 2 times a negative 5, which is a negative 10. And x is reduced, the power of x is reduced by 1. That is times the f function, which takes us back here. X to the 5th plus 13x squared. Okay. Oh, and now isn't that look fun? So now we get to clean up this algebra. And this is where I think I will stop. And we will pick up with distributing and multiplying all this out in video 2. See you then.